Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 7.2, which is going to deal with using functions to solve one variable equations. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to use functions to solve one variable equations. So today you're going to have two types of problems where they're either going to ask you to figure out when either something charges the same amount of money or when it costs the same amount, or you're going to have to be asked questions about how many months or years it takes for something to reach zero. And we're going to go through and use one variable equations to go through and solve these. Now there's two types of problem, and our first type is going to take part from example 1. Now example 1 is going to have us use a table or a graphing calculator to estimate the solution. Now that's what your directions are going to be, but I'm going to show you how to do this without a table or graphing calculator. So let's take a look at part A. Now for part A, it states that Susan wants to hire a babysitter for this weekend for her 3 children. She has two choices. Babysitter A charges $10 per child and $5 per hour. So that's babysitter A. Then babysitter B charges $15 per child and $2 per hour. So B is $15 per child and then $2 per hour. Now the question is, when will they charge the same amount of money? Now in this problem, we just need to figure out how many hours it takes for them to charge the same amount. Now, in this problem, they stated that she has 3 children. So we're going to use that 3 children to figure out what it is per child. So if we look at babysitter A, it states that babysitter A charges $10 per child. So it's going to be $10 per child for 3 children, which is $30, plus $5 per hour. So we're going to do plus 5x. Now, babysitter B is going to charge $15 per child. So for 3 children, 15 times 3 is 45. And then $2 per hour. So babysitter A, for this situation, is going to charge $30 initially, plus $5 per hour. And then babysitter B is going to charge $45 initially, and then $2 per hour. So from here, we need to go through and answer the following question. When will they charge the same amount of money? Because we want to know when these two are going to be the same amount of money. That means we want to know when these two expressions are equal to each other. So we're going to take this 30 plus 5x and set it equal to 45 plus 2x. So I now have 30 plus 5x equals 45 plus 2x. All we have to do is go through and solve for x, and then we have our answer. First step, when you do this, you're going to have a variable on both sides. And we need to move the variable to one side because I have a 5x on the left and a 2x on the right. Because the 5 is the bigger of the two numbers, I'm going to move this 2x to the left. Because it's plus 2x, we're going to subtract it. So when I subtract 2x, I then get 30, and then 5 minus 2 is plus 3x. Cancels out, and then we get 45. So I now have 30 plus 3x equals 45. So I'm going to rewrite that up here. From here, we're going to subtract this number, the 30, over to the 45. So let's go ahead and do that. So 30 goes away on the left side, and then we get a 3 equals 15, because 45 minus 30 gives me 15. Then all I have to do from here is just divide. So we're going to divide by 3. And then if I do 15 divided by 3, we end up with an answer of 5. So that means x is going to equal 5. So that means in 5 hours, the babysitters will charge the same amount. Now, up to that point, babysitter A will charge less, and then after that point, babysitter B will charge less. Now, we're not really too worried about that. We are just concerned about at what point will they charge the same amount. So for problems like example 1A that you see in your homework, they're going to give you something like babysitter A, babysitter B, painter A, painter B, electrician A, electrician B, and whatnot. You're going to set up an expression for each of those for part A and then part B, and then you're going to set them equal to each other and solve for x, and that will give you your answer. So with that said, we're going to follow that model and continue on in example B. So for example B, it states that John needs to hire a painter. Painter A is offering his services for an initial $175 in addition to $14.25 per hour. So this is for painter A. And then painter B is offering her services for an initial $200 in addition to $11 per hour. So painter B is $200 at the start and then $11 thereafter. So it wants to know, for what number of hours will the two painters charge the same amount? So again, we're going to follow the same format we did for A to go through and solve for B. So first, I'm going to set up my two expressions. For A, it's $175 initially, plus $14.25 per hour. So that means it's $175 plus $14.25 x. And then for painter B, she charges $200 initially, plus $11 per hour. So I now have my expressions that are going to represent the total cost for both of these painters and their respective cost. The question asks us, for what number of hours will the two painters charge the same amount of money? Because we're back to this idea of same amount of money, we're going to set it up like we did for part A, where we're going to take these two expressions, set them equal to each other, and then solve for x. So we have 175 plus 14.25x equals 200 plus 11x. So now all we have to do is just go through and solve for x, and then that's going to give us our answer. So I'm going to go ahead and move this up so that way we can just focus on solving. Our first step in this case is to move x to one side. Because I have 14.25x on the left and 11 on the right, I'm going to move the 11x to the left because 14.25 is larger. So by doing that, I'm going to go through and subtract the 11x over here. When we subtract 11x, this stays as 175. And then if I do 14.25 minus 11, and I did one too many, minus 11, we get 3.25, so this is plus 3.25x equals, the 11x cancels on the right, so I'm just left with 200. From here, what I need to do is move this 175 to the right. Because it's positive 175, we're going to subtract it. So we're going to do 200 minus 175, and we end up with 25. So I now have 3.25x equals 25. So from here, all I have to do now is just divide by this 3.25 to both sides. So if I do 25 divide by 3.25, I end up with, and we have an extensive decimal, so we're just going to go ahead and round to 2 decimal places. So I get a value of x equals 7.69 hours. And that is at what point these two painters will charge the same amount of money. And that is how we go through and solve part B. So when you get to the problems like example 1, whether parts A or part B, you set up an expression for both of them, you set them equal to each other, move the x to one side through subtraction, move the number to the other side through subtraction, and then divide by the number on x. And that will give you your answer. So for each of these problems, set up part A and B, subtract, subtract, divide. So each problem should be about 4 steps in solving for your answer. All right, so what I'll do is one more for example 1, just to give you another reference point, and then I'll leave part D for you to go through and do on your own for extra practice, or you can always reference my guided notes. So for part C, it states, and let's go ahead and move this up. So for part C, it states that Daniel is in need of an electrician. Electrician A is offering his services for an initial fee of $125 in addition to $45 per hour. So initial fee of $125 plus $45 per hour. So if I'm writing my expression for A, it's $125 plus $45 per hour. Then B, electrician B, is offering her services for initial $150 plus $38 per hour. So for part B, it's $150 plus $38 per hour. And then it wants to know for how many hours will both of the electricians charge the same amount of money. So we need to figure out when these two expressions are going to be equal to each other. So for part A, we're not for part A, but we're going to take electrician A and electrician B and set them equal to each other. So I get 125 plus 45x equals 150 plus 38x. So now that I have set up both my expressions, I've set them equal to each other, I now just need to subtract x to one side, subtract the number to the other, and then just divide. Because 38 is the smaller of the two between 38 and 45, I'm going to subtract the 38 to the 45. So if I go through and do that, we're going to do 45 minus 38, and I end up with 7. So I now get 125 plus 7x equals 150. Again, I'm subtracting the 38 over to the 45. So 45 minus 38 is 7. Next, I need to subtract this 125 over to the 150. So we're going to do 150 minus 125. And I end up with 25 as my answer. So we now have 7x equals 25. And then from here, all I have to do is just divide by 7. So if I divide by 7, we're going to take 25 divided by 7. And we end up again with a fun decimal. I'm going to round to 2 decimal places. So it's going to be 3.57. So that means in 3.57 hours approximately, the electricians will charge the same amount. And that is my answer for part C. So that is how you're going to go through and do example 1, whether it's parts A, B, or C. Again, when you get to those problems and they're asking about when they are the same amount, set up an expression for both, set them equal to each other, and then solve for x. All you have to do for your solving is subtract, divide, and then that will give you your answer. So with that said, that is really it for example 1. Now part D has us go through and talk about Mackenzie's looking to hire a clown for her daughter's birthday party. We're going to leave that one for you to go through and do if you would like, some extra practice, and see if you are on the right track. This is done on my completed notes. If you would like to see how it's done, if you want me to explain it later, just let me know. Alright, so with that said, let's go ahead and move on to example 2. Now, example 2 is going to kind of wrap up our problems for today and our second set or type of work today. So, example 2, again, is going to ask us to use a table or graphing calculator to estimate the solution. I'm just going to go through, again, and set up an equation to go through and solve instead of worrying about a table or graphing calculator. So, let's take a look at our first problem. So for part A, Audrey has $800 in a bank account that she uses to make automatic payments of her 101.51 monthly cable bill. So Audrey pays $101.51 for her monthly cable bill. If Audrey stops making deposits to that account, meaning she just has $800 in it, when would the automatic payments make the value of the account 0? Meaning, how long would it take for this $800 to go away? How many months would it take? So what you are going to do for this situation and for these types of problems is you're going to take how much they have, which in this case is 800, whatever the payment or whatever the charge is per month, so this 101.51, and we're going to use those two to set up an expression. So it starts with 800, so that's going to be our starting point. And then automatic payments of 101.51 are coming out of the account. So that means we are not going to add to the account, yet we're going to subtract. So that means we're going to subtract 101.51, and this is per month, so I'm just going to use X for my months. So that sets up my expression. To make it an equation, we need to set it equal to something, and we want to know when the account reaches 0, so that means we're going to set this equal to 0 to figure it out. So I now have 800 minus 101.51x equals 0. All we have to do is solve for x to figure out when or how long it takes for her account to reach 0. So first step, doesn't matter in which way you do it, if you either subtract the 800 to the right or if you add the 101 to the right. I'll give you an example of both as I go through parts A and B. So first, let's talk about subtracting the 800. Let's say I subtract 800 to both sides. So when I go through and do that, the 800 cancels on the left, and then on the right side, well, for the rest of the equation, I get a negative 101.51x equals negative 800. So all I have to do from here is just divide by this negative 101.51 to the negative 800. So let's go ahead and do that. So if we go through and divide, the negative 101.51 is going to cancel on the left side. So all I have to do now is just negative 800 divided by negative 101.51. And then that's going to give me, again, a fun decimal. We're going to round to 2 decimal places, and that's going to give me a value of x equaling 7.88. So that means in 7.88 months is when Audrey's account will reach 0. And that is our answer for example 2, part A. So whenever you get to the ones, when they want to know when an account or something will reach 0, you're going to take the amount they have initially, or to start out with, and then you're going to subtract it by how much the payments are or how much the charge is per month, set it equal to 0, and then just solve for x. So that is part A. I want to go ahead and take a look at part B. So part B is going to consider the same idea, just a different situation. So for part B, we have Craig has $1,850 in a bank account that he uses to make automatic payments of $400.73 on his car loan. So that means every month he pays $400.73 on his car loan. Now, if Craig quits making deposits to that account, meaning he doesn't increase the account by any money, when would automatic payments make the value of that account 0? So again, we want to figure out when this reaches 0. So to set this up, again, we're going to take the initial amount he has, the $1,850. We're going to subtract it by how much is coming out per month, which is $400.73. Because that's per month, we're going to attach a variable to it. I like to use x, you can use whatever. And then we want to know when it reaches 0. So we're going to set this equal to 0. Alright, so now that I have 1850 minus 400.73x equals 0, all we have to do is solve for x to get our answer. Now, for part A, I started by subtracting this to the other side, and then we divided. Another way is instead of subtracting this, we could add the x to the other side. So let's go ahead and do that real quick. So if I add the 400.73x to both sides, we end up with 1,850 equals 473x. Now, the reason why I added instead of subtracted like I did for part A is because this is a negative, so the opposite of subtraction is addition. So that's why I added to both sides. If I wanted to move this 1850 to the other side, because it's positive, I would have to subtract. So all I have to do now is take 1850 and divide it by 400.73. So if we go through and do that, so 1850 divided by 400.73, we end up with 4.6, and if we're running to two decimal places, instead of 6.1, it's going to be 6.2, because this is going to cause me to round up. So I end up with 4.62 for x, which means in 4.62 months is when Craig's account will reach 0. And that is how you do part B. So example 2 is our other set of problems where they want to know the value when the account reaches, or how long it takes for the account to reach 0. When you see those problems in the homework, take the initial amount, subtract it by how much the monthly charge or payments are, set it equal to 0, and then solve for x. So that is example 2. Now there is a part C, but just like with example 1, I'm going to leave the last one for you to go through and do on your own in practice. It just talks about Tara having $2,000 in a bank account. She makes a monthly mortgage payment of $900.01, and wants to know when the account will reach 0. So again, you would take this problem and you would set it up like this and just solve for x. So 2 types of problems today. One is going to ask you when they will cost or charge the same amount per hours, per month, whatever. Again, for those ones from example 1, you set up 2 expressions for whatever A and B are, set them equal to each other, and solve for x. When we're talking about an account reaching 0, take the initial amount, subtract it by however much per month, x, set it equal to 0, and then solve for x. So either you're going to set them equal to each other and solve for x, or you're going to set it equal to 0 and then solve for x. So that is it for our notes today on section 7.2. If you have any questions, as always, just let me know, whether next time you see me or via email. Be sure to use the completed notes as a guide on your homework. And that is it for today. So thank you guys for listening, and I hope you have a great rest of your day. All right, bye.